Hello and welcome to Powering Progress, the AFVi Partner Series. I'm Annalloyd Thomason, co-founder and CEO of Alternative Fuel Vehicle Institute. Joining me today is Steve Duricky, Global Platform Manager, who will share Parker's perspective on hydrogen's growing role in transportation, the technology behind it, and what it means for the technicians and fleets preparing for this new frontier. Steve, welcome to Powering Progress.
Thank you.
Hydrogen is getting a lot of attention across transportation and heavy equipment right now. From your perspective, why is hydrogen becoming such an important part of this conversation?
Well, Annalloyd, I think obviously there's a growing pressure in the industry for reducing emissions from various companies. And hard to electrify applications are areas where I think hydrogen is going to play a key role here. So, for example, electrification has been, obviously it's leading the way when we talk about reducing emissions. And light duty, passenger vehicles, obviously it's very prevalent, as well as medium duty vehicles. But when you start talking about some larger heavy duty vehicles and some of the construction market, really, when you start to get to that higher duty cycle and higher horsepower requirements, electrification just isn't cutting it there. There's just not enough battery technology. It hasn't evolved enough yet to justify using that type of technology when we're talking about larger vehicles. So I think hydrogen is going to play a role as we go forward. And the nice thing about hydrogen is there's a couple of different areas it can play. So you can actually burn it in an ICE, or you could use it to power a fuel cell. So I think that kind of gives the OEM, or the fleet, I should say, a couple of different options.
For heavy equipment and off-road applications, what makes hydrogen particularly attractive compared to other alternative fuels?
So compared to electrification, for example, the refueling time is critical, right? When you're working at a construction site and you're off-site somewhere, there just isn't a whole lot of opportunities to just plug in your electric vehicle. So the fact that we can actually bring the hydrogen to the site and then refuel it quickly, literally as quickly as diesel fuel, that makes it a huge advantage.
When engineers start designing hydrogen-powered systems, what are the most important technical differences compared to traditional fuel systems?
Yeah, that's a great question and a challenge for the industry, right? So everybody's familiar with diesel. That's the go-to fuel. But when we start talking about gaseous fuels, especially hydrogen, I mean, hydrogen's the smallest molecule, right, on Earth. And because of that small size, there's a lot of challenges. So one of them has to do with just the fact that it can permeate just about anything. So sealing technology is critical. And then storage of the gas, right, on a vehicle. So because hydrogen doesn't have the same fuel or the same power density that diesel does, you have to store more of it on the vehicle. So that typically requires much greater pressures to be stored, upwards of 10,000 psi.
So hydrogen embrittlement is often mentioned in technical discussions. Can you explain what that means and why it matters so much in system design?
Yeah, again, because hydrogen is such a small molecule and dealing with the pressures that we're dealing with, like I said, up to 10,000 psi, hydrogen can actually penetrate certain metals. And in doing so can cause some cracking and fatigue and premature failure. So we have a whole system that we like to design. So when we're talking about preventing hydrogen embrittlement, right, we're starting with a material that's a higher grade. So we're immediately going to stainless steel, but even stainless steel isn't good enough unless you're using a higher grade. So we recommend 316 stainless or above. And then once you have the material, some of the other things that are critical are just the fact that that material is traceable. And that when you're machining that material into your various components, whether that's a fitting or a valve, you want to make sure you have a quality process in place. Once you've got the components, you want to make sure you're putting them on your vehicle, that the design is a system that has, for example, you want to design for fewer leak paths, okay? And you want to also, once the piece of equipment is built, you want to make sure you're monitoring the systems on board that vehicle. So things like system pressures, system temperatures, and leakage are all critical components to make sure that vehicle lasts as long and is reliable as what they're currently using today with diesel.
Speaking of pressure and temperatures, how do those requirements influence the design of hydrogen systems?
Right. So again, there's a couple of different systems. I think I mentioned typically 10,000 psi operating systems for hydrogen. That's also 700 bar is the standard that the industry uses a lot. The other level is a little bit lower at 5,000 psi or 350 bar. But when you're dealing with pressures like that and gases, you got to make sure that the entire system, so your tube assemblies, your fittings, all your valving, the storage tanks, all of that has to be able to handle those higher pressures. And at the same time, there's a lot of thermal considerations that you need to look at. So for example, hydrogen, there's a couple of different standards out there that require the components in your fuel delivery system to be good to minus 40 degrees Celsius.
At a very high level, how do hydrogen internal combustion engines compare to a hydrogen fuel cell system?
That's a great question, and there's a couple of different things to consider here, right? So a hydrogen fuel cell, we'll say, is probably the farthest out there. There's some interesting things like the hydrogen that you're using in a fuel cell needs to be pure, needs to be very clean. They use the numbers, the 5 nines or 99.99% clean hydrogen, right? So typically where you see fuel cells today would be more on the road, right? Class 8 trucks, heavy duty trucks, where you know a little bit more about the environment. When you start talking heavy duty construction equipment, right now you're off road, you're dealing with an environment that's, dirty, dusty, a lot more contaminants in the air. So typically fuel cells today, they haven't gotten to that point where you can make it as efficient and as durable in those applications. So I think that's where an ICE engine, where you're literally just burning the hydrogen, you don't need that same level of cleanliness. You can get by with, a hydrogen purity level of around 98%. So I see when it comes to construction equipment, I see kind of the ICE hydrogen being a solution. And then eventually, once the fuel cell catches up, I can see construction market using that type of technology into the future.
What are the core components that engineers must get right when designing hydrogen systems?
So the number one, and probably the most costly, the most weight, is part of the storage systems. Okay, again, because we're trying to get the hydrogen vehicle, again, whether that's burning it in an ICE or using it in a fuel cell, you're trying to get that same longevity, that same operation that you get out of a diesel vehicle. So you need to store a lot of it on there. So there's going to be some storage tanks involved. That's probably the number one cost. It adds the most weight to the system. But then once you take that high pressure hydrogen in the tanks, you need to run it through what is called a pressure regulator. So the pressure regulator takes that hydrogen, whether it's at the 10,000 psi or the 5,000 psi, it takes it down to a much less pressure, something around 100 psi or even less. So that regulator is probably a key component that also needs to be considered. Sealing technologies, right? We offer a couple of different options. One is a metal to metal. Another is a elastomeric type of a connection. Both of those are good connections. And we'll talk a little bit more about that later. The other thing that is important is filtration, right? Like I mentioned, the level of purity that you're talking about for the hydrogen. When you're looking at a fuel cell, The other part of the equation is the air, right? You need to clean the air. So to, for a hydrogen fuel cell to work, you're taking hydrogen, you're taking the oxygen from the air and combining it, right? And that's creating electricity, and water is the a byproduct. So those are just some of the key areas that are kind of important when a design engineer is looking at the system.
As hydrogen adoption grows, what skills or knowledge gaps do engineers and technicians need to address?
Yeah, there's a lot, right? I mean, we're going from diesel fuel, which is a liquid at low pressures stored on a truck or on a piece of construction equipment, to now we're dealing with gaseous fuels, right? Hydrogen's a gas in most cases, and much higher pressures. So you're talking about an engineer that needs to understand high pressure gas and how that evolves in some of the different temperature and pressure ranges that we're dealing with. So it's quite a bit higher. And then obviously safety protocols are key. It's very critical. There's a lot of recent standards that have been introduced to help that engineer design that system to meet more of a safe standard approach.
Speaking of standards, what role do the industry standards and certifications play in the safe deployment of hydrogen systems?
Yeah, I mean, just like in any application, right? Standards are key as far as making sure that vehicle is safe and reliable. For the hydrogen market, there's been just a couple here recently, specifically kind of tied to North America. There's the CSA HGV 3.1 is a standard that gets used a lot and referenced a lot. And then also ISO, the 19887 is another standard that you hear a lot about. And what's been interesting here recently is the two standards, the committees got together and actually made sure that there was some cohesion between the two, which is really great for the OEM as they're trying to build these newer alternative fueled vehicles.
And why are standards especially important as hydrogen moves from early pilots to more broad commercialization?
Yeah, well, right now, everybody, hydrogen has got a lot of different, I say, people have a lot of different opinions on hydrogen. And I think the biggest thing is safety, right? You think of hydrogen and you think of the Hindenburg, right? And gaseous fuels and explosions. And I think what the industry needs is the comfort. The public needs to understand that we've been using gaseous fuels in the industry for decades. I think the Artemis 2 is just heading back from the moon. Well, that entire ship was launched with liquefied hydrogen, right? So I feel like the standards kind of just brings a little sense of safety and reliability to the system design that these engineers are building.
Many experts describe natural gas as a bridge to hydrogen. Why does that transition make sense from an engineering standpoint?
Well, just like I was referring to gaseous fuels, right? Where hydrogen is fairly new, natural gas, methane, if you will, CH4, has been around for over 20 years, at least 2 decades. We've been utilizing it in the United States. There's over 135,000 natural gas vehicles in the U.S. Most of those you'll see refuse trucks that have been driving through your neighborhoods, operating on high pressure gas. There's 23 million natural gas vehicles worldwide, right? So I feel like being able to handle and have an experience with refuse trucks driving through neighborhoods, having gaseous fuel at 3,600 psi, right? It's stored at a high pressure with a similar system, and just the reliability, the safety, a lot of those concerns have been tested and proven over millions and millions of miles.
So from a systems perspective, what engineering elements carry over from compressed natural gas systems to hydrogen systems?
The nice thing is it's very similar system. So if you're familiar with understanding how natural gas works from a storage system and then from your fuel delivery system, For the most part, you can handle hydrogen. Now, obviously, hydrogen is a little bit smaller of a molecule. So, the sealing is a little bit more critical. Some of the pressures that I mentioned are higher. So you need to take that into consideration. And of course, I mentioned that hydrogen embrittlement. Um, but for the most part, understanding how a natural gas fuel system works is, you're halfway there when you're now going to be upgrading to a hydrogen gaseous system.
How does that continuity help organizations prepare their teams and their infrastructure for hydrogen?
Well, I think it helps, kind of start designing, building that engineering backbone that a company needs, right? You start with natural gas and a vehicle design utilizing that. And then you really, from there, you can work with companies to help further align that capability in understanding how hydrogen works. Like I mentioned, there's a lot of similarities, but there are a few additional things that need to be considered when you're starting to look at hydrogen.
And while hydrogen is exciting, there are several alternative fuel technologies that are already deployed today. Which ones currently are proving successful in heavy equipment or fleet applications?
Like I mentioned, electrification really is leading the way. For example, light duty or lower horsepower applications are already moving to electrification. So like a mini excavator is a good example of a piece of construction equipment that operates today and is successful utilizing batteries. However, like I mentioned before, when you start to build and get a larger piece of equipment, maybe something with a higher duty cycle, higher horsepower requirement, that's where the battery technology just doesn't cut it anymore. So there's a couple of solutions. So hybrid is one option, right? Hybrid is basically taking you still got an ICE, but it's a smaller engine on board along with the battery. And what that allows you to do is get that same energy density that you're looking for and duty cycle. So hybrid systems, I would say, is probably very popular today and is literally building kind of a bridge. Like we talked about natural gas, building a bridge to hydrogen. I almost look at it as a hybrid system currently building a bridge to a fully electric. And again, these are for specifically the heavy duty, larger type vehicles that we're talking about.
Why is heavy equipment and off-road sector such an important part of the alternative fuels conversation?
Couple of different things I wanted to share here. So first of all, when we think about, again, we've been talking both on-road and off-road, right? So when you're talking about on-road heavy duty vehicles, right, utilizing diesel today, I don't know if many people know this, but there's about 3 million heavy duty Class 8 trucks on the road today, right? And unlike you or me, we might travel 10 or 15,000 miles a year. These trucks are going 100,000 miles a year on average, right? And their fuel economy isn't as great, right? Where we might get 20 miles to the gallon, they're getting about 6. So I'm going to try to do my math here real quick. So if you take 3 million vehicles, right, and 100,000 miles per vehicle, that's 300 billion miles, okay? You divide that by your 6 miles per gallon, and you get about 50 billion gallons of diesel fuel per year being consumed. So that by far is the largest opportunity. If we're looking about, reducing emissions and reducing carbon, you want to target the heavy duty Class 8 truck initially. And that's where the industry has been really focused on, I think. The next segment is the construction heavy duty market. I think that is probably the next area where there hasn't been a whole lot of focus on regulation and cleaning some of their equipment up. So I think that's kind of where we're headed now.
What makes those applications uniquely challenging when it comes to fuel transitions?
Yeah, the big one is you just don't have the refueling stations available like you do for diesel, right? So if you're dealing with a over-the-road heavy-duty truck, and that's utilizing hydrogen, there just isn't the hydrogen infrastructure today. When you talk about natural gas as a alternative fuel, yeah, you've got quite a bit more opportunity to refuel your vehicle. Now, when we're off-road and we're talking about, construction sites that could be out in the middle of nowhere, you're going to have to deliver your fuel to you. And in a lot of cases, that's being done today with diesel. The nice thing with some of these gaseous fuels is you can deliver those just as easily on a truck. Again, you're storing it at high pressures to get the volume that you need. But then the refueling time is very similar to diesel. So I feel like there is an opportunity to utilize some of these cleaner alternative fuels within the construction market in the future.
If you had to leave organizations with one guiding principle as they think about hydrogen adoption, what would it be?
Yeah, start small. If you got a fleet of vehicles that are currently running on diesel, maybe just try one vehicle, or maybe it's a smaller vehicle on an alternative fuel. And maybe you don't even want to jump right to hydrogen. Maybe just try something like with a natural gas vehicle. There's a lot of opportunities. I think if you move to just trying natural gas, you're going to learn how a gaseous fuel at high pressures operates, right? How to handle it, how the vehicle operates. And then over time, you can maybe transfer that knowledge and that ability to a hydrogen type of vehicle. And again, maybe you start with a hydrogen ICE before you go to a hydrogen fuel cell. Each one of those steps are a little bit cleaner when we're talking about these types of fuels. The engineers, right, today that people are looking for and hiring are that they're they want to make an impact, right? And companies, I feel, that are pushing the envelope when it comes to some of these cleaner technologies, that's where engineers are going to want to work for, right? They're going to want to work for a company that's going to make an impact. So that company is going to be able to obtain and retain some of the best talent out there when it comes to engineering. So I feel it's a great opportunity for fleets and companies to pursue kind of a cleaner, more emissions-free environment. And at the same time, you're going to be able to draw and retain some of the best talent out there.
What should fleets or OEMs or other operators be doing now to prepare for hydrogen, even if they're not deploying it yet?
There's a couple of things, right? So the first thing you want to do is evaluate kind of the infrastructure that I talked about, right? I mean, again, depending on the gaseous fuel you're looking at using, natural gas, CNG, there's a little bit more of an infrastructure available than there is for hydrogen. And again, that's the same whether you're on road or off road, right? So I think infrastructure is kind of important. Technicians understanding some of these new technologies. When you're bringing in vehicles, into the maintenance garage to repair or replace components, you're going to need to have technicians that are versed in this new technology. And then just, again, kind of monitoring some of the standards that are out there. The industry's, it's kind of I don't want to say it's in flux, but a lot of these standards are just now being released. So it's kind of important to stay up on kind of the latest that's out there. And you want to work with a company that's supplying these components that have familiarity with a lot of these standards. So a lot of the products that you're going to be supplied meet them. And that's kind of that's a great opportunity just for the customer to feel safe and that they've got a reliable system that's been tested and certified.
When you look at the future of hydrogen in heavy equipment and transportation, what gives you the most confidence about where the industry is heading?
Yeah, so I feel, again, whether it's on-road, heavy-duty Class 8 truck, or off-road construction equipment, there's several companies out there that are making a difference, right? For example, I think of Toyota when I think of fuel cells. Toyota introduced the Mirai, which was a hydrogen fuel cell vehicle, passenger vehicle. They're not selling many, However, they've learned a lot in 10 years since they've been having these vehicles on the road. And that's allowed them to really improve their fuel cell and expand it to larger types of vehicles. There was another joint venture that took place not that long ago between Daimler and Volvo called Cellcentric, right? And they teamed up together again to develop a fuel cell to be able to handle the durability and reliability and just kind of give you that diesel-like performance, right? What was interesting here recently is that that collaboration between Volvo and Daimler has recently been expanded to now Toyota's joined as part of Cellcentric. So I really feel you've got three very large, probably 80% of the market between those three working together to make fuel cells work. So it's not a matter of, it's going to happen. It's just a matter of when it's going to happen. And then with regards to off-road applications in the construction market, again, there's several companies, JCB, Liebherr are a couple that come to mind that offer hydrogen. Now they're looking at utilizing hydrogen in an ICE, but then there's another company even closer, Cummins. Cummins has a line of fuel agnostic engines where you can literally run a engine on either it's natural gas or hydrogen. So I feel, there's a lot of companies that are looking to hydrogen in the future. We're not there yet, but I think slowly as more and more companies test and build prototypes and spend some money, I feel like we're going to get there eventually.
Steve, thank you so much for joining us today.
Well, thank you, Annalloyd, for being such a great host. And I was glad to have an opportunity to talk a little bit about something that I'm very passionate about.